have two examples here that I want to work through so that I can show you what it looks like algebraically to have infinitely many or no solutions. We already talked about graphically that we're going to have either lines that intersect or are the same line all the time, intersect all the time, same line all the time. So we have infinitely many solutions. Or we're going to have two parallel lines that have no solutions. So first I'm going to show you algebraically. Now, the best way to solve this one would be by substitution because the x is by itself here. There's no coefficient. That's a pretty good way to solve this one. Also, if we look over here, as I demonstrated on the previous example on the other video, I could have also said, oh, well, I could maybe divide this by 2, but then we see the 7 here and we have the awkward fractions, so that doesn't really work. Let's go ahead and just add 2y to both sides. And now we can substitute in for x over here. Two y minus 3 equals x. So instead of writing x, I wrote 2y plus 3 equals x. So instead of writing x, I wrote 2y plus 3. Distribute. Now, look what happens. We get that 6 equals 7, which is actually not true. So I know algebraically, since I reached a false statement, we're going to have no solutions. Graphically, let's see what would happen. This equation would be y equals 1/2 x minus 3/2. This equation right here would be y equals 1/2 x minus 7/4. Already you can kind of see what's going to be going on here. Both of these equations have the same slope, but a different y-intercept. And so, if I were to graph them, I would get parallel lines that don't intersect. No intersections. No solutions. Let's look at the other example. So here, just looking at this, I could use elimination by multiplying this one by 1/2 on both sides. And I can multiply this one by 1/5 on both sides. So here I would get 3x minus 5y equals 6. Here I would get negative 3x plus 5y equals negative 6. Now, let's go ahead and add these together. Now everything crosses out and we get 0 equals 0, which is a true statement. 0 does equal 0. So this is going to give us infinitely many solutions. Now, if we were going to graph it, let's put these both into slope-intercept form. Solving for y here, we get that, I'm going to say y1 equals 3/5 x minus 6/5. And here, for y2, we would get 3/5 x minus 6/5. If you were to graph this, you would get the same exact line. And therefore, you would have infinitely many solutions.